Yeah. Welcome. The floor is yours.
Thank you.
Go ahead.
Good morning, everyone.
Morning.
I hope everybody's had their coffee. It's my job to wake you all up. So it's great to be here. It's also really good to see, when I was looking at the agenda, topics from across the industry at this conference. Over the years, AT&T has been part of this incredible group of innovators and researchers, and I'm happy to have the opportunity to speak with all of you today. My presentation today will be in 4 sections, and you might find the presentation to be different than most of the other presentations. I would like to give you a much broader view than maybe just a singular, in-depth topic. However, you will see we will start with the broader view. I'll first like to share a historical perspective of the role of communication industry and what it has done to fundamentally alter the socioeconomics of our globe. Secondly, I'll share or touch upon the rich history of innovation at AT&T. But thirdly, I'll dive deeper into topics that should be germane to all of you today, which are topics of 5G, IoT, and SDN. When I'm discussing those topics, I'll all along the way present to you some challenges also that these massive transformations are facing. And those challenges for you are basically an opportunity. And it'll be really, one purpose that I could achieve today would be to revitalize the participation and rev up the connection between IEEE and the industry, because the collaboration has always delivered success. And there's no time like today to really address that with gusto. Finally, I'll also pose some call of action to the community. So let's just step back for a moment and just take a wider lens to understand the impact of the communication industry. At the advent, I think the slides are not able to move here, looks like. At the advent of the railroad network in Great Britain, back in 1838, the number of passengers' journeys increased 17 times over a period of 15 years. But more importantly, the railway network brought along with it social, economic, and political progress like never before. There was rapid development of new and existing businesses, surge in trade, and of course, increased competition that revitalized the economy. Now, compare this to the communication network. An equivalent time period of 15 years from 1995 to 2010, the growth in global internet users was 40 times. So some key observations in the two simple compare. The pace and reach of change is growing beyond our imagination. Communication networks are rapidly changing, modernizing, and ultimately benefiting life across the globe. In fact, this industry has had such a massive impact that even more so than us, economists and political leaders are asking the question, or shifting from asking the question, who's connected to who's not, because they want everybody to be connected since it impacts everything that is in our society. The communication network is also the oxygen for the software economy. The two together are making life simpler and maximizing the derivation of value from existing assets. Take Uber, for example, is the world's largest taxi company, yet owns no vehicles. Let me offer a unique perspective based on data from Uber. Uber Pool accounts for 20% of all Uber rides. Just for the first 3 months of this year, that means 1.8 billion gallons of gas that would have otherwise been burned didn't happen. That reduces the human impact to climate change dramatically. And with 60 million total guests, Airbnb is the world's largest accommodation provider, yet owns no real estate, reusing idle time at private residences. As we reflect on these dramatic changes in the socio-economic fabric, let's not forget that communication is the underlying foundation for the software economy. And that's why it's really a perfect time for us to be here to discuss what's coming. At AT&T, we have a rich history of uncovering significant opportunities through research, innovation, and collaboration. So let me just touch upon that real quick. AT&T's innovation has led to 8 Nobel Prizes and many other industry solutions and awards, of course. But consider some of the most iconic contributions. The transistor in 1947. In 1958, we developed the laser, which fundamentally changed technology. And in 1976, we developed fiber optic networks. And as recent as this year, we are introducing the AT&T Integrated Cloud and eComp, which is basically the operational support system for the software-defined network. And we are introducing these in open source communities. That's an important point for you to take home. And I will discuss both of these in much greater detail in a few minutes. These and many more intelligent design innovations were developed by AT&T. In fact, IEEE even has an award named after our founder, Alexander Graham Bell. We take incredible pride in our innovation, but more importantly, we take pride in our collaboration. It is through different perspectives, philosophies, knowledge, structures, and even cultures that many of these brilliant innovations were born in the first place. Through partnerships, always with academia, industry leaders, researchers, development communities, and of course our own employee base, we have the potential for unprecedented formula for success of the future. So moving on to the next section, which is basically going to be the heart of the presentation here. At AT&T, we have taken the first step in defining, in partnership, as I was earlier referring to, the first step in defining the future through these emerging technologies, 5G, IoT, and software-defined network. Let me touch upon IoT to start with. I'll begin this section to talk about some of the industry trends. It has been termed as the next industrial revolution. IDC estimates 35 billion things will be connected to the internet by 2020, which is more than 4 times the world population, 35 billion things, not computers. According to Reuters, IoT is anticipating it to be $1 trillion business in only a few short years. Just imagine the unlimited potential in these areas of our life. Businesses will be enhanced through better logistics and coordination. The automobile industry will be transformed through enhanced safety and convenience. And health can be monitored in near real time, potentially saving people's lives. Through these examples and many more, we are connecting the connected. AT&T's approach is to build on the foundation of our best-in-class network and provide a full-stack solution for IoT. So let's begin at the bottom layer, the device layer. At AT&T, we have certified over 1,000 device types to connect to our network. We have also launched our own starter kit to help people rapidly plug in their own hardware prototype with low-cost LTE hardware. Moving to the network layer, we are the first to launch LTE-M, the latest LTE technology connecting a wide variety of IoT endpoints through low-powered, wide-area solutions, also known as LPWA, as the standards are emerging. This will not only lower cost for connected IoT devices to the LTE network, but in cases increase battery life up to 10 years and allow better coverage underground and deep inside buildings. The success of the network is ultimately realized through our excellent platform architecture. Through our security portfolio, we provide secure APNs and world-leading security solutions like NetBond and AVPN leveraged within the IoT portfolio. We are enabling much-needed device management based on Open Mobile Alliance device management and lightweight machine-to-machine to build a platform. We provided solution to store data in the cloud and rapidly connect devices to any cloud with our machine-to-machine platforms. Flow Designer simplified development and dramatically reduced delivery times for IoT developers, which has enabled commercial and and other maker hardware platforms to rapidly connect to cloud solutions. We also took Node-RED, which is an excellent open source prototyping solution, and enabled cloud execution environment inside of the AT&T cloud. Finally, we look to ultimately deliver industry-leading complete solutions. Solutions for smarter cities, smart lights, water leak detection, connected cars with AT&T Drive, and many, many more other such solutions. It's very important to see the full stack in the industry going forward. I think one of the challenges to the academia, researchers, and others that I would propose is not just think about the micro, but think about the macro. And think about the full stack integration of north, south, as well as east, west. There's so much opportunity to be harnessed for research, development, as well as industry collaboration, that once you increase your vantage point and understand that, it can really enrich research, development, and also collaboration with the industry. So moving on, what does this mean? Let me give you some specific challenges from this exploding industry. Some key areas that need attention. Let's start first. We need to improve the sensor technology itself. Devices need to be designed innovatively to safely and effectively fit in their natural habitat, in the natural environment. Take, for example, body sensors, things that would sense your heartbeat. How would they be placed inside of you? Those are some of the basic challenges that sensor technology has to overcome. And there is incredible amount of research possible in this space. Secondly, we understand that not all devices will be designed at the same level of value or security. That is why it's critical for software management to be highly secure. Limiting the potential effects of device without the requisite security features, or compensating for their performance issues, or compensating for many other shortcomings in the lower level device. So software management platform, their architecture, and their scalability is going to be another very important challenge that we would love to collaborate and partner to overcome. Finally, from a management perspective, it will be imperative to have thoughtful design and standardization of tools, methods, and interfaces that allow hundreds of devices to be onboarded ubiquitously to create an end-to-end connected ecosystem very rapidly. It is critical that we develop a platform for success today in order to manage the complexities of tomorrow. The number of things is growing, but their beneficial effect cannot truly be realized without the introduction of 5G. This technology will usher in a new era of communication. Through 5G, we expect enhanced network speeds anywhere from 10 to 100 to even 1,000 times faster than today's average 4G LTE wireless connections. And we are already aggressively working to help shape 5G standards. The fundamental difference that will distinguish 5G from previous generations is the diversity of use cases that it must support. At AT&T, we look at 5G from two perspectives. One, enhanced mobile broadband, and two, what we considered, and we just talked about, massive IoT. 5G will need to manage and enable the explosion in IoT devices. We're looking at using 5G in high-speed fixed wireless home connections, improved coverage, and radio access networks, RAN, virtualization. Because of this, 5G will need to be deployed faster, and 5G has to have lower latency and operate on higher frequency bands. To make this a reality, we have taken a leading proactive approach to 5G, understanding its true value and importance. We are making real tangible progress. We currently have lab work in 4 major cities. In these cities, we are simulating real-world, high population density environments, similar to what a customer might experience, say, at a ballpark. We will accelerate the consumer and business connected experience. The vision of 5G is to enable the wireless network to essentially do what a fixed network can do, but do so at low latency and higher throughput. Enhanced mobile broadband targets 5 to 10x speed versus LTE speeds of anywhere between 5 to 12 megabits per second. This becomes important as 50 megabits per second is often thought of as the unofficial threshold for customers to run video applications on multiple devices. Perhaps more important than speed, 5G standards will enable the handling and management of the upcoming massive IoT explosion that I'd earlier referred to. And many features considered to be 5G requirements will be implemented as LTE advanced extensions in advance of a full 5G rollout. Now, moving on to the next topic, we'll talk about the software-defined networking, big data, and open source. Combined with our spectrum, AT&T is in a unique position to support next-generation 5G applications quickly and efficiently. 5G is ideal for these bandwidth-hungry applications because it will support multiple radio interfaces, enable more spectral efficiency, and take advantage of software-defined network and network function virtualization and cloud and container technologies. And we are already well on our way. As I earlier referred to, the wired and wireless lab trials are taking place in many of these locations. We are also collaborating with many other industry companies, Ericsson, Intel, Nokia, to work on 5G solutions in our labs to find and resolve key standard issues consistent with 3GPP so we can launch 5G at scale very rapidly. Our approach is aggressive yet collaborative. To successfully implement a 5G network capable of handling the many dimensions of a connected future, we again must look at the challenges from the device level all the way up to the integration layer. First, to posit a few challenges for collaboration opportunities. First, due to the variability of use cases and the different frequency ranges, circuit technologies must be improved for further penetration and enhanced distance. Secondly, SDN and NFV architecture technologies will allow systems to be built with higher levels of abstraction. In fact, we need the systems to be built with higher levels of abstraction. In 5G, what we need is taking care of, by abstraction, taking care of issues like network slicing, tailored virtual instances, and of course, improved control capabilities of these sliced bandwidths. Finally, while it may be possible to build a separate system for each use case, this will not be economically viable and would lead to incredible network complexity. 5G will need to be a system of systems that can meet all the needs of all the users. This brings me to the third and maybe the most important part of my core presentation here, the software-defined network, the very fabric which ties all of this together. In the last 8 years, data traffic on our wireless network increased 150,000%, and we expect total network traffic to grow over 10 times between now and 2020. We're asking a network model designed years ago for modest and predictable increases in voice traffic to adapt to a world of streaming videos, high-definition games, and photo-intensive social media. The economic gravity of this reality necessitates that we transform our approach to building networks. And an answer to this challenge is to transition from purpose-built network appliances to open white box hardware that is virtualized and controlled by our AT&T Integrated Cloud, also referred to as AIC. We're also liberating network functions from the same purpose-built appliances into standalone software components and managing the full life cycle of this virtualized network functions via AIC in conjunction with both global and local software controllers. Taking this approach prevents vendor lock-in and allows us to have an open, flexible, and modular architecture that serves the purposes of scaling to meet the explosive demand at lower cost, increase speed of feature delivery, and provide much greater agility. Our goal is to virtualize and cloud-enable 75% of our entire target network architecture using this software-defined approach by 2020. Fundamentally, the concept was simple, yet the implementation is ripe with complexity. We began our transformation from the ground up, prioritizing the core platform of our SDN solution, the AT&T Integrated Cloud. AIC has the following characteristics. It's a global distributed cloud. It is integrated. AIC has a single integrated code base for both enterprise and network workloads. It is built on OpenStack, which sits at AIC's core and is integrated through our robust set of APIs. We based AIC on open source purposefully, as we believe it is the next generation of development engine for the network. Open source provides many benefits. The direction of the product is collaborative, leveraging a broad user base to define the software roadmap. Open source can be downloaded. It is easily accessible, and it is modifiable through continuous integration and continuous development tools and techniques. There is increased control over product direction, and innovation is borderless, allowing open source to tap into global community of software developers. Through ours and others' engagement in open source communities, we have seen tremendous growth in solutions. Open source communities are helping solve many of the gaps in software-defined networking transformation. The first gap was within the data center. We needed a local controller to build carrier-grade network functions. We worked with other open source communities to develop the local controller and integrate with OpenStack's Neutron APIs. The second gap was that we needed capabilities to enable and manage a plethora of high-end communication services across the wide area network and integrate them with existing systems. Hence, at AT&T, we developed a new framework or global controller called ECOMP, which stands for Enhanced Control, Orchestration, Management, and Policy. ECOMP provides a design time and runtime framework that tightly integrates all our systems with AIC, as well as enables and manages the wide area network. ECOMP will be the platform, with a core platform for the future SDN, and will provide robust, self-managed, self-healing automation. ECOMP and AIC are essentially our answer for SDN, and AT&T is committed to open source ECOMP via the Linux Foundation. To learn more about ways to contribute to AIC and ECOMP, please refer to the IEEE website, and next to my name you will find in the agenda, you will find the links which can help you understand these two concepts and the progress we have made much better and how to collaborate with us. As we transform our network to next generation SDN, our network needs to be able to interoperate with existing physical network. Therefore, from an automation perspective, it is imperative to operate seamlessly across the two domains. Here's another challenge for you. Hence, while we develop SDN and ECOM and its management frameworks, we are simultaneously advancing existing OSS from monolithic architectures to platform-based microservices, thus enabling the hybrid of physical and software network to be controlled by this Uber OSS architecture. And while innovation flourishes, new challenges continually develop. Hardware must be redesigned. SDN controllers must be designed in open to allow for this increased speed and managing of these complexities. Finally, service design and creation will need to deliver near real-time implementation of network design in all of its variability. So I hope I have communicated to you the major advancements that AT&T is making in the world of 5G, IoT, and SDNs, and our fervent desire to work in collaboration with you. In the previous sections, I've touched on the key challenges, which translated are also opportunities. However, as we evolve, more challenges and thus more opportunities come for you. So here's a three-legged stool for you. I would say join the many technology areas and participate in those, because I anticipate those three technologies to be the most critical bulwark for the network of the future. Determine the level of impact. Where would you want to participate? At the device level, at the software level, at the integration level, and collaborate with the industry leaders. And with that said, I would say thank you very much, and I really appreciate how we have been collaborating in the past, and how we will, I'm sure, will continue to collaborate in the future to redefine the communication networks across the globe. Thank you.